Okay, this video is about service panels, specifically NEC 250 and how to pass your service panel inspection. You want to remember to always check with your local AHJ, authority having jurisdiction, and your local codes and state codes. All the code references today are going to be from the 2020 NEC National Electric Code. One of the most important things about any service panel inspection is bonding and grounding and the main bonding jumper. So we're going to talk a little bit about the main bonding jumper. So what is the main bonding jumper? The main bonding jumper typically is the bond at the service panel that is between the grounded conductor, the neutral, and the case of the service panel. And this is where all the other grounding and bonding usually occurs or is tied together at this point. 250.28 of the NEC tells us what material is supposed to be for the bonding jumper. So it's got to be copper, copper clad, or some other corrosion resistant material. The NEC goes on to tell us that it can be a strap, a screw, or it can be of the wire type. 250.24 of the NEC goes on to talk about grounding of service supplied systems. 24B goes on to give us the requirements for the main bonding jumper, and it tells us it has to be unspliced, or it shall be used to connect the equipment grounding conductors and the service disconnect enclosure, so the case, to the grounded conductor within the enclosure for each service disconnect. So 24C talks about the grounded conductor, and it talks about the grounded conductor needs to be routed with all the ungrounded conductors to each service. And this is for services that are 1,000 volts or less and are grounded services. So that grounded conductor is required to be brought to the equipment whether or not line to neutral loads are being used. So as an example, a fire pump controller, oftentimes an electrician will say, it's 208, I don't need the grounded conductor. And if it's a grounded service being supplied by a service for the fire pump controller, which it typically is, that grounded conductor needs to be there so there's a fault path back to utility. Okay, so in a typical residential service, like I have up on this slide, it shows you a 7200 single phase transformer with a secondary, a 12240 secondary, center tapped and grounded. So we have a grounded service here. And we'll talk a little bit more about how the bonding jumper to the grounded conductor works. But in a grounded service, as NEC indicates, we need to bond the grounded conductor to the case. And that's what you see in this picture here. So we have a typical service, 7200 volt service, primary, and a secondary that's center tapped and grounded, which is a pretty typical service in my area. So what happens if we have a system fault, a ground fault? What do we need all this for? What do we need this bonding jumper for? What's it doing? So that's what we're kind of getting to now. How does all this work together? How does our grounded system work with the utility system to clear the fault? And that's what we're going to talk a little bit further about. And with a system ground fault, whether it's NM cable or Romex or EMT or metallic wiring methods, which part of the country I'm from, it's mostly EMT on the inside or metallic wiring on the inside. And then on the outside, you'd find mostly heavy wall or some EMT applications, but it's going to work the same way. During normal operation, electricity is trying to complete a circuit. It's trying to find its path back to utility so it completes the circuit. And what happens in a fault condition, if it faults to a case, some normally non-current carrying metal of the system, something that's normally non-current carrying, if it faults to that, by providing that path back to utility, you can clear the fault easier. So by providing grounds in an NM system or by the EMT ground in a metallic system, by properly grounding and bonding the service panel and also equipment and devices, you're creating a low resistance path that will cause a high voltage flow back to the grounded conductor and back to utility, which will open the breaker a lot quicker. Table 250.66 of the NEC helps us to size any supply side bonding jumpers that are required for concentric knockouts or other items that you would need a supply side bonding jumper. So 250.66 would give us that sizing based on the ungrounded conductor size. And any bonding jumpers are again important because you have a solid bonding and grounding path back to the utility. 250.41 tells us a little bit about the why, and it tells us that systems that are grounded have to be connected to earth. And what this does is it limits higher voltages by things like lightning, transformer faults, or some type of a other larger fault. And then it also helps to stabilize voltage during normal conditions. And it does this by providing not a low resistance path, but it provides a low impedance path and helps to give some type of a reference to ground for the electrical system. 250.50 tells us about the grounding electrode system and what qualifies, what are the qualifiers for a grounding electrode. And also it tells us that if it's present at the building, we have to use it. So that is often one of the things that comes up is, do I have to use all grounding electrodes that the NEC requires? If they are present at the building, that has to be part of your grounding electrode system. So 250.52 provides us a list of qualifying electrodes. So they talk about a metal underground water pipe, if it's applicable, if it's more than 10 feet into the ground. Concrete encased electrodes, so the UFERs, ground rings, rods, pipes, and plates. Other listed electrodes or ground plates, so it has to be listed for grounding. It could be some metal in the structure of the building that qualifies for a grounding electrode conductor. So those are all found in 250.52 of the NEC. So in a typical residential inspection, what we're going to look for is the water pipe. And in our area, the water pipes are all metallic, and they qualify because they are at least 10 feet of earth contact. Our systems in this area of the country are all metallic, and they all connect from one home to the other. So we're going to look that we have a proper bond of the conductor to the water pipe, and that there's also a jumper around the water meter. We're going to verify that there's at least one 5/8 inch copper rod, a minimum of 8 feet in length. Also that there's an inter-system bond that you see in this picture. This is one example of an inter-system bond for cable and phone. So in new construction, what we're requiring is the concrete encased, or the UFER as it's known, to be utilized as one of the electrodes. 250.104b talks about other metal piping likely to become energized. And at the water heater, typically you'll see a bond of the hot and cold because of the dielectric unions that are breaking that connection. And then sometimes you may see a bond at the gas line because the equipment grounding or bonding at the furnace. So that would be covered under 250.104b. As I mentioned before, 250.53.2 talks about the supplemental electrode. So you may need to supplement that rod if you don't have 25 or less ohms resistance to ground. If you do add that rod, it can't be any less than 6 feet from any other grounding electrode of the system. This would be an example of the concrete encased electrode, or the UFER as it's known. Before the footing is poured, it has to be at least a minimum of 20 feet in contact with earth, and it has to be a minimum of a 1/2 inch in diameter, so typically a number 4 bar. One of the new requirements in the 2020 NEC and cycles beyond that is 230.67, which requires for residential surge protection. So for a residential panel, we're looking at the surge protector and if that was installed. Now there's a new requirement in the 2020 NEC and cycles beyond this, 230.85, which talks about emergency disconnects. I'm going to make a separate video on that. A lot of areas of the country weren't impacted at all by that. The area that I'm in, that was something new for us because we didn't have meter mains or service panels on the outside. So that's something, as I said, I'll talk about in another video, but it's something to be aware of, that 230.85 starting in the 2020 NEC. Okay, to put this all together, when we're inspecting a service panel, what we're looking at is on the panel itself, we're looking at conductor sizing meets table 310.16 in the 2020 NEC. We're looking that the bonding and grounding is correct. So it's typically going to be a screw in a residential panel. So do we have a main bonding jumper to the case? We're looking for any supply side bonding jumpers and that they're sized per table 250.66. We're looking for a duct seal that's required in our area because there's differences in temperature from outside to inside. We want to see duct seal that's required by the NEC. Then we're going to look to see that we have grounding electrodes in place. Do we have the rods outside and are those bonded to the grounding electrode system? And do we have the water ground typically in our area inside? And if it's new construction, is there a UFER or the concrete encased electrode? And that kind of sums up what we're looking for in a service panel inspection. I hope this helps you pass your next service panel inspection. Let me know in the comments if there's any other videos you'd like me to do. And if you liked the video, give me a thumbs up and remember to subscribe. And thanks for watching.